Just confirm me once the screen is shared.
Okay.
Investment return, the mean, the both part I have done with you, and the variance.
Yeah.
Yeah. Standard deviation also I did with you, and we were doing the sum, the
Yeah.
mean and the variance of that one, right? And we were started with the semi-variance. Okay. Screen shared?
No.
Okay.
Yeah. Yes.
Semi-variance. Let's continue from here. So I told you that why the semi-variance is important, because it considers both upside, that is the positive, and negative, that is downside. Okay.
Yeah.
So semi-variance isolates, what the semi-variance does, it isolates the risk of returns falling below the mean. So if you see what is the difference between variance and semi-variance, variance was measuring the average squared deviation from the mean, considering all fluctuations. And semi-variance is doing what? Semi-variance is measuring the average squared deviation from the mean.
Okay.
But only for values, here is the constraint, below the mean. That is losses. So now I told you that for all the things you have discrete case and continuous case.
Yeah.
So here also you have same. So that is very easy calculation. Whenever we are having discrete, that is PMF. And whenever we are having continuous, that is PDF. So last day we did with, now let's see. For a, this is I'm doing for the semi-variance.
Okay.
For a discrete random variable X with possible values X and say the probabilities being Pi, what will be the semi-variance? So the semi-variance will be summation of X less than mu and X minus mu squared P of X as X. Okay. So what is the step-by-step explanation, like how we do it? Obviously, first I will identify the mean and then I will calculate all the values of X which are below mean for this.
Okay.
And then we will compute the standard deviation from the mean. This is very important. And then we will multiply each squared deviation by its probability. And then we will sum up them to obtain finally the semi-variance.
Okay.
Okay.
Yeah.
So here, if I do it with a question, the type of question, because you have sums. So suppose consider an investment with 3 possible returns. What are they? 5% with probability 0.3, 10% with probability 0.5, and minus 5% with probability 0.2. Okay. So
Okay.
here, if I have to compute the mean, how I will calculate? Mu will be 5 multiplied by 0.3
Mm.
plus 10 multiplied by 0.5, and it will be minus. So minus 5 multiplied by 0.2. So if we calculate what it is coming,
5.5.
5.5%. This is step 1. Then what is my step 2? I have to find values which are below mu.
Yeah.
Which are there? So the returns below 5.5% are 5% and
5.5.
minus 5%. Okay. So now if I compute the semi-variance, how I will now the computation of semi-variance. So how I will compute SB of X, that is 5 minus 5.5 square multiplied by 0.3 plus minus 5 minus 5.5 square multiplied by 0.2.
Yeah.
So that will be minus 0.5 square multiplied by 0.3 plus minus 10.5 square multiplied by 0.2. Okay.
Mm.
So it will be 0.25 multiplied by 0.3 and 110.25 multiplied by 0.2 minus square. So
20.
finally, it will come to 0.075. 25, 3,
Yeah.
22.05. So that will be 22.125.
5.
So this is for if you are given the discrete case, you do like this. But if
Okay.
you are being given for, say, probability density function,
Mm.
probability density function, what it is that? For continuous.
Okay.
Okay. So for that, you can say that is always integral. Means you have to remember this is very
Mm.
easy. Whenever you are being given the discrete, then what it is the expectation.
Okay.
Okay, not the mean. Okay, mean is the average. This is expectation. And for continuous, whatever it is, we do PDF, and that is integral. And this question is very important because it comes.
Okay.
Okay, semi-variance. What it is? So for a continuous random variable x with probability density function PDF. So function of x or semi-variance is given by is v of x. So that is minus infinity to this. So x minus mu squared f of x dx. So if I do the step-by-step calculation, then how I will do? First, I will consider only values of x, again, that are below mean.
Mm.
And then compute the squared deviation. That is from mu. And then we have to integrate. Okay. So if you say that what are the key difference between the variance and semi-variance? So quickly,
Mm.
variance and semi-variance. What is the difference? So here it measures the total spread around the mean. Okay. And
Okay.
here it measures the spread of negative deviations only.
Mm.
Okay.
Yeah.
And then what is the mathematical formula? Summation of x minus mu square p of x. Okay. And this is x less than mu, x minus mu square p of x. Okay. Now, what will be the investor's concern? Can you tell me? Here,
Mm.
it captures both positive and negative fluctuations. And here, it focuses only on losses. So, ignoring the positive deviation.
Okay.
Okay.
Yes.
And what is the risk interpretation? It is suitable for risk assessment and it is more relevant for investors who fear losses. Noted?
Yes.
Okay. So now, why you might say that every time I told you that
Mm.
why it takes only written below the mean? The question might arise in my mind.
Mm.
Why? Because some argue that only that investors only dislike the possibility of low return. Obviously, I am investing with the motive of profit motive, and in
Okay.
markets also we have done that everybody is profit motive. So you
Yeah.
can say it is investor psychology and risk perception. On the both thing you have already done on the first part about how to calculate the expected utility and the probability and see the risk amount and then consider. Correct? So
Yeah.
it's based on the risk perception. The concept of semi-variance is rooted in behavioral finance. So investors are more considered about loss than gain. For them, more important is loss. If there is loss, they won't do.
Okay.
And we know that traditional variance treats upside and downside deviations equally. Deviations equally. Okay. So, for example, if a stock return is higher than expected, so investors benefit. They don't see this as risk. But if the stock return falls below expectation, then that is a risk. Why? Because they might experience financial loss. So their headache is this loss. Now, why investors focus on downside risk? Focus on downside risk because there in behavioral economics,
Excuse me.
there is a prospect theory by Kahneman and Tversky. Very interesting. People decide accordingly how you frame them, nudging basically. So this
Okay.
states according to behavioral economics, they worked on this only, Kahneman and Tversky. So they states that people losses more intensely than they appreciate equivalent gains. And real world investment decisions, they prioritize strategy that reduce downside risks rather than avoiding all fluctuations.
Mm.
And risk covers investors, say the retiree, okay, or conservation portfolio manager. They care more about protecting capital than chasing high return. Okay,
Okay.
okay. So from this, you understood that the variance chart, the variance,
Mm.
if I say the measure, the variance and semi-variance. And here what it considers and investor relevance. Okay. So for variance and for semi-variance. So here it both upside and downside deviations from mean. And for investors' return, it measures total fluctuation. But what it does not differentiate between good and bad volatility.
Okay.
Okay. And according to semi-variance, it is only downside deviations. And it is focuses only on the risk of losses. So investors do not worry about the higher than expected return, but they dislike the loss. So
Okay.
semi-variance aligns better with real-world risk perception. And if you see, basically people more, they are stock only. Means if you see the trending topic is always stock. Okay. So if you see portfolio management, here the key applications goes with the portfolio management. And then you have risk assessment. And then you have options like hedging and all. Okay.
Mm.
So from this, we conclude this part. Now do a question. Let's do a question. Then the next slide you are having. Question 2. You are given the probabilities of investment return. So what are the probabilities? P of X is minus 5, 0.1.
Yeah.
P of X is minus 2, 0.2. P of X is 0, that is
Yeah.
0.3. P of X is 3, that is 0.25. P of X is 6, that is 0.15. Now what I have to calculate? I have to calculate mean and the semi-variance of return. Okay. So
Yeah.
how I will calculate the mean? The summation associated with the probability. So let's
Mm.
quickly do that. Expectation of X is summation of XIP, that is X is XI. So that is minus 5 multiplied by 0.1 plus minus 2, 0.2 plus 0 multiplied by 0.3 plus 3 multiplied by 0.25 plus 6 multiplied by 0.15. Okay. So
Yeah.
here, let's do, it is minus 0.5
Yeah.
and then it is minus 0.4, 0.75
Mm.
and 0.9.
Yeah.
So finally, my answer will be
0.75.
0.75. Okay. Mean
Yeah.
return. And what is the semi-variance formula goes with?
It's the same expected value minus.
Yeah. But X minus mu square variance, no?
Yes.
So it cannot be same. Okay. Yes. So the identifying values below the mean is X minus 5, minus 2 and 0. So we will compute the square deviation and multiply them with probability. So
Oh.
SV of X will be minus 5 minus 0.75 square multiplied by 0.1 plus
Minus 2.
2 minus 0.75 square multiplied by 0.2 plus 0 minus 0.75 square multiplied by 0.3.
Yeah.
So it will come minus 5.75 square multiplied by 0.1 plus minus 2.75 square multiplied by 0.2 plus minus 0.75 square multiplied by 0.3. 0.0625 multiplied by 0.1. 5625 multiplied by 0.2 plus 0.5625 multiplied by 0.3.
Yeah.
So 33.0625 multiplied by 0.1. Okay, so this I have done. I will do the calculation. 3.30625 plus 1.5125 plus 0.16875.
Mm.
So if we add it, what it is coming?
4.9875.
So it comes to 4.99. So the mean and the semi-variance is being done. Okay. Okay. Now there is another question. We have to calculate the semi-variance of y given mu as 5 and this as 3. So how I will calculate? The semi-variance for y given 5, 3 is 0. But this result seems incorrect due to a numerical issue. So
Mm.
why? Because we have to do it with the semi-variance formula. Because n5, 3, semi-variance of this is, it will come 5 and 3, it is given.
Mm.
So we have to do now, the question is, what is the semi-variance formula?
Is it the integration one
Square
or
deviation.
that one? Yeah.
Square deviation. So we have to put on that. We are being given mu and this. If you remember, last day I did with you, if there are two constants.
Yeah.
So how to write that?
Which one?
The mu, if there are two errors, mu and if there are two constraints. Last I told you, if there are two constraints, you told me why I am considering two, because there are two constraints.
Mm.
Just
Let me check.
you remember, or you have
Yeah.
revised.
I did, but I don't see the.
Okay, I got it. Okay. So here it will be basically SV of x being summation of x less than mu, x minus mu square, P of I x.
Yeah.
Correct?
Yeah.
For discrete case. And for continuous case,
It's integral.
just write it down, okay?
Mm.
The integral. Today only I told you.
Yeah.
Mu x minus mu squared f of x dx. Just the way I did. You do one thing, you just try with this formula, and next you tell me, okay, you practice, because or else it will be a problem. Okay.
Okay.
Okay. So all there are many formulas which I have done with you. Okay. So one by one, go on practicing at home so that you don't forget, because it will be very much difficult. Okay.
Yeah.
Okay. Okay. See this question if you can do. This question you try. Okay. This is very easy.
The question 4.
Yeah. Last one was question 4.
Yeah.
Question 3
Yeah.
with this formula.
Okay.
Okay. Just nothing. You just put the value and you just find it out. That's it. You just try. If you're not able to do, you tell me tomorrow.
No problem. Okay.
With the following density function. This is another there. This is the trickier one. This I am doing.
Okay.
F of x is 0.00075. 100 minus x minus 5 square. So for it is between x to 15.
Yeah.
So how I will calculate this?
Using the continuous formula, the integral
Yes,
one.
yes. So let's put it. We are given the PDF. How
Yeah.
to find the PDF? The formula I have just now
Yeah.
wrote f of xx. That is 0.00075 100 minus x minus 5 square
Mm.
for minus 5 x to 15. Okay.
Yeah.
So first we have to calculate the mean. If you remember the step. So the mean will be mu. That is minus 5 to 15
Yeah.
x
Okay.
f of x dx by again minus 5 to 15 f of x dx. So if I use numerical integration, then that is mu of it will come 5.
Okay.
Okay. You
Yeah.
have to do this integration. You know u by v rule?
Yeah.
Yeah.
There's
So
also
accordingly,
if
yeah.
you don't also just if you don't like divide right, you will still get 5.
Yeah, yeah, yeah.
Okay.
But here it is mu. So
Uh,
since in the formula I told you two constants, so look at
yeah.
like this because for PDF it is integral and for that it is expectation. You might know if they cut the marks. Correct.
Okay.
Okay.
Yeah.
And how the semi-variance is calculated for the same? It's the same
Mm.
formula B.
X.
So SV of x will be minus 5 mu x minus mu squared f of x dx by minus 5 to 15 f of x dx. So we know if we integrate, it will come over values below the mean.
Yeah.
That is mu being 5.
5.
You will calculate, you will get this answer.
Okay.
Okay.
Yeah.
Just I'm showing you
Mm.
this one. Total probability is how much?
1.
1. Total probability is 1.
Yeah.
So if you do integration, if you just do the integration, it is f of x dx, x is given. So here f of x is 0.0075 100 minus this square. You elongate this, so x square minus 10x plus 25. So then comes a value and then differentiation of that one and accordingly because this is dx. Then you put the value, integral means what? Minus 5 you are putting once time and 15 you are putting once time. Then you are getting the value. What you get, that is the answer.
Oh. Okay.
Okay.
Yeah.
You try this thing. And if there is any problem with the integration also, you told me. Then I will do 2 or 3 sums.
No problem.
Okay.
Yeah.
Okay. So now probability of shortfall. PSF.
Mm.
What is that? It measures the chance of return smaller than some benchmark L. And for continuous C. For continuous, it is integral. And for discrete, it is mean.
Mean. Okay.
Okay. So the
Yeah.
probability of shortfall basically is a risk measure. What it calculates? It calculates the probability that a return X falls below a certain benchmark L. It basically helps investors and financial analysts to assess the likelihood of receiving undesirable return. Now, if you say higher PSA, like what is the probability that my investment return will be lower than a specified level? So if it is higher PSA, and if it is lower PSF. So if it is higher PSF, then greater risk of underperforming the benchmark. Forming the benchmark. And lower PSF means lower risk of falling below the benchmark.
Mm.
Risk of falling below the
Benchmark.
benchmark. So now what is PSF in continuous distribution? So PSF of XL in continuous distribution is f of x dx. Okay. So fx is what? The PDF that of the return x and the integral. So suppose question 6 or 5 it might be.
Five.
Suppose investment return follows a normal distribution.
Okay.
Say x of n 10 4 square. So here say the mean return is what? 10.
Okay.
Say here standard deviation square. So standard deviation will be 4 forward times.
Mm.
So then if I want to calculate the probability of return which fall below 5%, then L equal to 5. Then what it will be? P of SFX 5 is P of x less than 5. So that is P of x minus 10 by 4 less than 5 minus 10 by 4. So then it will be P of z less than minus 1.25. So if you use the standard normal table, then z less than minus 1.25 means it comes to 0.1056. So the probability of shortfall will be 10.56%.
Okay.
Okay.
Yeah.
Now, what is PSF in discrete distribution? This was continuous.
Mm.
So PSF in discrete distribution. That will be for discrete distribution, the probability of shortfall is calculated by summing the probability of all value below L. So PSF of XL is summation of X less than L. So P of X is X. So now suppose if I say you that an investment has a following possible returns. What are the returns? Say how to determine return and you have the probability. Okay. So here minus 5%, 0%, 5%, 10%, and 15%. So what are the probabilities? 0.1, 0.2, 0.3, 0.25, 0.15. So what is my benchmark here?
3.
My benchmark? No, 5%. I have not given you any benchmark till now.
Oh, okay. Okay. Fine.
Okay, so this is the question only. So L is 5%. So we will sum up the probability for x less than 5%. So
Okay.
that means PSFX5 will be P of x minus 5. So plus P of x0 because minus 5 and 0 are there which are less than
Okay.
except 10 and 5. So what are there? That is 0.1 and 0.2. That comes to 0.3.
Mm.
So how you will interpret the probability of shortfall? How will interpret?
It's 30%. So
Yes, 30%.
it's a.
Multiplied for percentage, so it is 30%.
Mm.
So 30% meaning there is a 30% chance that the return will be low, below 5%.
Oh, okay.
30%, not 0.3, okay, percentage. That the return will be below 5%. Correct?
Yeah.
So this is for your probability of shortfall. Now you have expected shortfall, expected shortfall. Next.
Yeah.
Expected shortfall is given by, again, for continuous and for discrete. And for continuous, it will be the integral, and for discrete, it will be integral expectation.
Yeah.
So expected shortfall, and that will be for continuous and discrete. And how I write the formula? ESF XL will be minus infinity to L minus X fx dx. This is for continuous. And for same for your discrete is expectation of x less than L minus X P of Ix. And that is for discrete distribution. Okay. So basically expected shortfall is what? We can also say expected shortfall as conditional value at risk. That is C var, which measures the expected loss, measures the expected loss beyond a certain threshold. So it goes beyond probability of shortfall.
Okay.
It goes beyond probability of shortfall by considering P of S means short form probability. Okay, you write PSF.
Mm.
PSF probability of shortfall by considering not just the probability of shortfall, but also the magnitude of loss. And unlike where you have done var, which only provides a cutoff point. So var provides a cutoff point. An expected shortfall gives an average expected loss. So
Okay.
again for continuous and for discrete.
Mm.
So expected all for distribution. Okay. So how I will get? For a continuous distribution, the expected shortfall will be given by X and we have L. So minus infinity to L, and L minus X f of X dx. So L is my what? Benchmark return or the threshold.
Mm.
So here L is my benchmark return. And what is X? X is the actual return. Fx is the PDF for everything of X. PDF means?
Probability density function.
Yeah. And the integral will accumulate the difference between the L and the actual return. That is X. For all values below L, weighted by the probability.
Mhm.
So if I suppose the investment return follows a normal distribution, say 10 and 4, then I can, with the given standard deviation and the mean, I can put up this and we can find the the normal distribution case, find the expected shortfall for the continuous distribution.
Yeah.
So now expected shortfall for discrete, what it will be? For discrete distribution, expected shortfall. The formula ESF XL summation of X less than L, L minus X, P of X equal to X. So here it is only considering the values of X that are less than L again. And L minus X represents shortfall amount for each loss. And the probability P of XX weights the contribution of each shortfall. So if I give you a question,
Mm.
8 or 7, suppose an investment has the following possible returns. So what are they? The returns being and the probability. So it is minus 5%, 0%, 5%, 10%, 15%. Okay. And it is 0.1, 0.2, 0.3, 0.25, 0.1. Now, if I tell you that the benchmark is 5%, so how will be the expected shortfall? Okay, let's do.
Mm.
Expected shortfall will be minus 5 multiplied by 0.1 plus 0 minus 5 multiplied by 0.2 because it is expected shortfall.
Yeah.
So it is minus 10 multiplied by 0.1 plus minus 5, 0.2. So that comes to minus 1 and minus 1. So that is minus 2. So expected shortfall will amount to 2%.
Yeah.
On average, losses below 5% will amount to 2% shortfall.
Okay. Mm.
Okay.
Yeah.
So this expected shortfall is important because this captures the tail risk, more conservative risk measure and used in risk adjusted return measure. Okay. So
Yeah.
this is about expected return. And here the main important thing is L. L is what?
Threshold benchmark.
For the benchmark.
Yeah.
The benchmark is a critical threshold. Like it says minimum return to break even. Like the minimum return required to avoid a loss. If the return falls below this level, the investors will incur negative performance. As we can see that the shortfall is below and it achieves solvency. Solvency means there is a minimum return
Okay.
a company or financial institution to remain solvent and continue. So used by banks, insurance company and pension fund to determine financial stability. It is basically like market index, S&P, Nifty. Okay,
Mm.
they set some investment goal, and it is basically practical thing.
Okay.
Okay, so it's variance, VAR, and expected shortfall we did.
Mm.
Now again a question is there. Okay, let's see 20. You are given a probability of investment return in percentage. So P of X is minus 5, 0.1. P of X is minus 2, 0.2. P of X is 0, 0.3. P of X is 3, 0.25. And P of X is 6, 0.15. So if I'm being asked, I have to calculate the expected shortfall with L being 3. So how I will calculate? I know that for the discrete distribution, what is the formula? Let's do it. ESFXL is summation of x less than L. So L minus x, P of x equal to x.
Yeah.
So I will write it down. What are my L? L is 3. We sum over the values of x that are below 3. So
Mm.
L minus x is the shortfall amount for each loss.
Okay.
And P of x is the probability of each return. So below 3 means what? X is minus 5, minus 2, 0. Why?
Yeah.
Because 3 and 6 are not below 0.
Yes.
So this P will be considered. So here, if I compute expectation of this is, we will do with 3 of minus
Minus.
5 multiplied by 0.1 plus 3 of minus 2 multiplied by 0.2 plus 3 minus 0 multiplied by 0.3.
Yeah.
So then
2.7.
3 plus 5, yeah, let's do it.
Yeah.
Let
Okay.
me see. Plus 3 plus 2, 3 minus 0, 0.3. Use calculator.
Yeah.
Okay. 0.1 plus 5 minus 0.2 plus 3 minus 0.3. So it comes 0.8, 1.0, 0.9. So this is 2.7. Okay. So my expected shortfall is 2.7%. Average loss beyond that level.
Okay.
Okay.
Yes.
Okay. So today it is this much. Next I will continue with value at risk. Okay.
Okay. Thank you.
Thank you. Bye bye.